Oh yeah, okay, we got it now. It's a matter of being familiar with vMix. Good evening, everyone. We'll start again. 4 minutes past the hour already. Okay. This is VK3 Echo Kilo Hotel, the official station of the broadcast of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 Charlie Sierra Juliet in Narre South. Good evening to everybody. We're broadcasting on 3541 kilohertz in the 80 metre amateur radio band, simulcasting on the medium wave service, 1865 kilohertz AM, and we're streaming via the World Wide Web on our YouTube channel, which can be found at VK3CSJ. Just look for the live symbol. Also, you can find the link or a link to the YouTube channel via the ASV website at www.asv.org.au under the Radio Astronomy tab. And right, where did that come from? Anyway, yes, mass distractions. All right. So having said all that, we're also broadcasting through the Melbourne television repeater, VK3RTV, and I might just make mention that it is in full HD tonight. Yes, we are broadcasting high definition through the Melbourne television repeater, VK3RTV, Channel 1, digital Channel 1, and we have received our SR boards. Not sure where that's coming from, but anyway. Yes, it's the pictures on the TV looking particularly good at the moment. So, hopefully it'll hold out for an hour. Anyway, reports, please, for the TV pictures, and would be appreciated. You can send those reports via email to vk3ekh@gmail.com, and that is the email for tonight, vk3ekh@gmail.com, and we are viewing the inbox as we... Right, I'm going to have to turn that down. I think that's Uncle Mike, but is that on 23 centimetres, Richard? I'm not sure. I'll just... Oh, okay. All right, that's Uncle Mike. Thanks, Mike. All right. Now let's get into the swing of it. As I usually do, we give a bit of a quick rundown of what the Society is all about in its 100th year of operations. And 200 years... No, 100 years, that's it. 200, well... Yeah, that's right. Okay. The Astronomical Society of Victoria, founded in 1922, comprises over 1,600 members throughout Victoria and Australia. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for the study among its members. Monthly meetings are held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night. Meetings start at 8 p.m. at the Maulia Hall National Herbarium in Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available Burwood Avenue, Dallas Brooks Drive, and within the surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located in Melbourne Observatory. Receipt of the ASC magazine Crux containing news, articles, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible to members too. The Society also has a number of 200mm reflectors available for short period loan so members can try before they buy. Regular Society Club Night meetings are held on the first and last Fridays of each month at the Lodge, the Society's property in Burwood, which Could be sold by now. Anyway, members are encouraged to use the Society's instruments located there to gain first-hand experience in telescope use. These instruments include the 508 equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne, which is where I'll be heading to tomorrow. There are a range of instruments available for members to use that are large to only with appropriate training, which range from 300mm to 1000mm in aperture. There's also on the same site an 8.5 metre fully steerable radio telescope, which members can access with involvement to the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in particularly include, deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology, astrophysics, historical studies, and research and astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra bulletins, which are sent out via email to members every other week. Please note that the ASV will conform to all government health directives. ASV events may be required to be cancelled, moved, or postponed. Information can be information on the Society can be found if you write to the Secretary, the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. Now, from now, I'll start to slowly go down. Anyway, that's it for the ASV. And we should now get on to the rest of tonight. I forgot to mention Discord. There's also a Discord chat window. The Discord chat window can be found via the ASV website at www.asv.org.au under the Radio Astronomy tab. And look for the link to the ASV Friday night broadcast, and it will be a little icon with a radio telescope dish on it, and you click on that and you'll be into Discord. You can sign in alias or with your name or anonymous, whatever, doesn't matter. But it'd be nice to know who it is we're seeing. As we speak, there's a few folks on the chat window already. Uncle Mike, Kim, VK5FUSE, that's VK3XL was Uncle Mike. Steve, g'day Steve, VK3SPX, been a regular lately. Martin, VK7JH down at good old Tassie. Got an itchy leg, I'm just scratching my other leg, that's what I'm doing. Steve, Steve, VK3VRS is fixed, or something's fixed. Kim again, Martin and VRS and Martin again. So there you are. Let's make that chat window speak. Come on, everybody, get onto the chat window and say g'day. Okay, inbox. G'day Don, VK3HDX has your report there. I've got a new mouse on this other computer, so I've got better control now. So it's reporting good singles on 80 metres, 5.9 plus 30 and 20 for 160, and RTV, good pictures and everything else. Excellent. Thanks, Don. Okay. And Andrew has just sent an email. It's just come through as we speak. Andrew, VK3KISS, KIS, checking in and watering via video feed. Watering? Yes, you are watering via video feed. 80 metres, rather noisy tonight. Oh, I see. Okay. But watering? Maybe that's meant to be watching. All right, just getting into the swing of it here. Okay, next on the scheme of things. You're tuned to ASV Radio, VK3 Echo Kilo Hotel. more information about the ASV, just go to the ASV website at www.asv.org.au. And there you'll be greeted with "Welcome to the Astronomical Society of Victoria." And just underneath that is a membership link, and you can join if you wish. But everything that's going up with the ASV is presented on the front page, so you can see what's all happening there. There's a public stargazing event, but I can't see the picture. There's meant to be some picture there, but I'm not sure what that's about. The Astronomical Society invites you to another public stargazing night at Caulfield Racecourse Reserve. See the night sky through our volunteers' telescopes. So there you go. That's something for the public. There's apparently bookings needed. It's a cost of $10 per person. Okay. Anyway, so July 23rd. It's Saturday, July 23rd, 7 p.m. to 10 p.m. Caulfield Racecourse Reserve. The Astronomical Society is inviting public to a stargazing night at Caulfield Racecourse Reserve. Anyway, more information about that can be found on the ASV website. And then later in the year, there is something called the Sea Lake Astrofest, which is slated for October 29 to November 1. Sea Lake and Lake Tyrrell, in conjunction with the Bullock Shire Council and the Sea Lake community, the Astronomical Society of Victoria would like to announce the Sea Lake Astrofest 2022, kicking off over the Melbourne Cup weekend. That weekend. The Astrofest aims to bring science and astronomy to regional Victoria with a weekend full of activities and events for people of all ages. So again, that information can be found on the ASV website on the home page there. Sea Lake Astrofest 2022 over the Melbourne Cup weekend. And there's, like I say, all information there about that. Okay, I think I'll go to Sky Notes now. This is VK3EKH, the official station of the Astronomical Society of Victoria. Alrighty then, just going back to my inbox there. Now, what was the last date I mentioned last week? I think I went as far as Skylab. Did I mention Skylab? I think I did. Yeah, I'll kick off with the 14th of July. Yeah, 14th of July 1965, Mariner 4 makes the first controlled flyby of Mars and returned the first close-up images of the planet. 1965. On the 15th of July 1975, the Apollo-Soyuz test project mission occurs, and an American Apollo module with 3 astronauts launched with the first Saturn rocket, and a Soviet Soyuz craft with 2 cosmonauts rendezvous and dock in Earth orbit. So that was the 15th of July 1975. On the 16th of July 1746, birth of Giuseppe Piazzi, discoverer of the dwarf planet Ceres in the asteroid belt. I never get the pronunciation of that right, I know that. Anyway, Giuseppe Piazzi, discoverer of dwarf planet Ceres in the asteroid belt. Also on the 16th of July 1994, Jupiter is struck by over 20 fragments of comet Shoemaker-Levy 9, with Earth-based telescopes and Hubble Space Telescope observing the unique event. And what they don't mention there is that there was a swag of radio astronomers out there setting up radio receivers tuned to around 20 megahertz with the one-off chance of being able to detect the actual impact of these fragments hitting into the upper atmosphere of Jupiter. Between probably about 3 or 4 groups in the radio astronomy section at ASV, and this is around about the same time I joined the society. Monash University were also doing the same thing. They were setting up a radio observatory up at the Mount Burnett Observatory, building a folded dipole type antenna across the little reservoir that was up there, and had a receiver and computer doing a lot of recording and monitoring. So the late Doug MacArthur was also used his 8.5 meter dish to focus onto Jupiter, and he also measured impulses at 400 megahertz as these comet Shoemaker-Levy impacts hit into Jupiter. It was an exciting time for a lot of people, the science community, but for a bunch of average radio astronomers, it was even more exciting because we just didn't know whether or not we would be able to detect these impacts. Fortunately, NASA provided approximate time impacts of these fragments, so we had a rough idea of when to actually listen for increases in noise on above the average noise floor, and we believe we did detect something between us. We had chart recorders going, huge, massive Kent chart recorders. So that's KENT, and these things are boat anchors, but they did a magnificent job at charting the variation in noise floor at 20 megahertz. It was an exciting time. There should be more comets impacting with planets around here, I think. The next date, what was the next date? The 20th of July 1969, Apollo 11 moon landing, when Lunar Excursion Module Eagle touched down on the Sea of Tranquility, in the Sea of Tranquility. On the 21st of July 1969, first human set foot on another world. At 12:39 p.m. Australian Eastern Standard Time, Neil Armstrong becomes the first person to step on the moon. He is followed 20 minutes later by Buzz Aldrin, while the third Apollo 11 astronaut, Michael Collins, remains in the Command Service Module Columbia in the lunar orbit. Armstrong and Aldrin are on the moon for 21 hours and 36 minutes. I remember it well. Yes, and I'm thinking now of the movie The Dish. If you haven't seen the movie The Dish, Rob Stitch's film, highly recommend it. Okay, that's enough of the dates. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre South. Good evening to Graham, VK3 GRK, who's popped up on the Discord channel. And we have Mr. Costigan, who's just sent in an email. He's he says we're up at LMDSS listening in. Catch you tomorrow. Yeah, g'day Phil and the guys. that's a nice little surprise to see that there. Thanks, Phil. Excellent stuff. And good evening to everybody that's up there at LMDSS. We'll be up there hopefully around 11ish to see what's been going on up there. Anyway, all good stuff. All right. First article for tonight, Sagittarius A twinkles. A new simulation shows our galaxy's central black hole is feeding off nearby stars. July 7. And I've got a picture here too to bring up. So if you're not seeing the TV repeated, the YouTube channel is the next best thing here. So let me just bring up the image. Right, there it is. And there's a bit of video attached to that too, which I'll bring up in a tick. Back to the article. Earlier this year, scientists released the first image of the supermassive black hole at the heart of the Milky Way, called Sagittarius A, or Sagia A for short. The image doesn't actually show the black hole, however, but rather its shadow on the material, the glowing material that surrounds it. Light cannot escape a black hole once it's been pulled beyond its event horizon, the point of no return, and what most people picture when they think of a black hole. But perhaps counterintuitively, some black holes, including Sagittarius A, have disks of gas that rapidly orbit around them. This accretion disk is the material that the black hole is feeding on. But not even a black hole can gobble down all this food at once. Instead, it must wait for the material to lose momentum through friction. It's this friction that causes the gas and dust around the black hole to glow, making it possible to actually spy the otherwise invisible object and even capture an image of its shadow, which is more or less what you're seeing on the screen right now. Now, I'll go and run this video. It goes for a couple of minutes. I don't think there's any sound associated with it, but it's kind of an animation, a simulated aspect to it. Have I got the right video here? That's the next trick. Oh, there it is. Okay, coming up on the screen. All right, there it is. That goes for about just over a minute. So I'll just go back to the article. Where are we? Light cannot escape a black hole once it's been pulled beyond its event horizon, the point of no return. So I've already read that. So for a long time, however, astronomers struggled to model how the gas around Sagittarius got there. So what you're seeing on the screen now, let me just check that. Oh yeah, okay. Oh yeah, that's working. The researchers compared 3 different models they developed separately to the observed flickering of Sagittarius A. They found that a stellar wind model in which the gas was blown off from stars near the galactic center was the best match. While not a surprising conclusion to those that study black hole accretion, it is a promising step in our understanding of the supermassive black hole that beats at the heart of the Milky Way. The results are published in the Astrophysical Journal Letters on June 17. Let me just run that. I haven't got it looped. Restart, play, and where's the loop on that? There it is. So I've got that looped. Now, okay, so that's only a short article actually. Black holes are the gatekeepers of the known secrets, said Lena Merkichkov and William D. Logan, who are members of the Institute of Advanced Study in Princeton, New Jersey, and lead author of the new study in a press release. In order to better understand these mysterious objects, we are dependent on direct observation and high-resolution modelling. So yeah, so that's what you're seeing there on the TV is a black hole simulation of our best guess of what's happening at the accretion disk. Pardon me, near a black hole. All very interesting. Okay, you're tuned to ASV, VK3EKH. All right. Back to me. Next article. I'm just waiting for the coffee to kick in. Okay, we have one image associated with this article. Not much to really look at, but it's part of the article nevertheless. Celestial features found in the South American desert. Chile's Atacama area boasts rare and wonderful astronomical insights. July 6. Atacama. I can never pronounce that right either. Okay, this image, let's just bring that up. Okay, so what we're looking at here is the Piedras Rojas. Piedras Rojas is located nearly 13,000 feet above sea level, with a rare lake and salt flat in the Chile's Atacama Desert. So that's what you're seeing there, is a sea level. It's 13,000 feet above sea level, and it's a rare lake and salt flat. Okay, so there it is. All right, let's see what the article's talking about here. Hang on, I'm just going to do 2 things at once here. All right, back to me. Rare natural phenomena and geological mysteries are commonplace in the world's driest non-polar desert, the Atacama of northern Chile. Fields of geysers blast boiling water. Salt flats stretch for miles, punctuated by flamingos in lagoons, and occasionally stunning desert flowers burst into bloom after rare rainfall. Some spots in the Atacama Desert see just a few millimetres of precipitation per decade. Wedged between the Pacific Ocean and the Andes Mountains, this land of dry air also claims crystal clear night skies glowing with the southern constellations year-round. The entire point for tourists and many researchers is the artsy Bohemian village of San Pedro de Atacama, situated on a high Andean plateau 30 miles west of Bolivia. Visitors, it turns out, can also spot celestial marvels in the dusty sand at their feet, unique glassy black rocks that are scattered across the northern Atacama had long baffled geologists until November of 2021, when a study of geology pinpointed identical meteoric grains in short cosmic minerals. In these rock specimens, combined with other variables, the study's authors concluded that a near-Earth comet likely exploded at low altitude, raining down fiery minerals that melted sand across the desert. Perhaps most surprisingly, the extraterrestrial event seems to have occurred 12,000 years ago, quite recently in astronomy and geological terms. Hunter-gatherer groups likely occupied the region and might have witnessed the harrowing space shower. So that's celestial features found in the Southern American desert, July 16. Thanks, astronomy.com. All right, next article. This is VK3 Echo Kilo Hotel, ASV Radio. China's ambitious plan to find the first Earth 2.0. And there's a bit of an image associated with this, but it's just an artist's impression of something. The second Earth. Despite several high-profile missions to find an Earth-like planet orbiting a Sun-like star, astronomers have failed to find one. Now, the Chinese are launching their own space telescope to hunt for Earth 2.0, June 27. I've been holding over on this article. The Kepler Space Telescope made some of the most exciting discoveries in astronomy. Launched in 2009, the telescope observed 13 million stars until 2018, when it was deactivated. During that time, Kepler discovered over 2,600 planets orbiting other stars. Some are entirely unlike anything in our own solar system, forcing astronomers to invent two new classes of planet. One or two of Kepler's discoveries even orbit in the habitable zone of their parent star, albeit around red dwarf stars that are rather different from our Sun. This was hugely exciting because this temperate region in which liquid water can exist has conditions thought crucial for the existence of life. But for all that, Kepler ultimately failed. Its mission was to find another Earth. In other words, an Earth-like planet orbiting a Sun-like star, but in nearly a decade of observations, Kepler found not a single Earth 2.0. That was partly because Sun-like stars turn out to be noisier than expected and so required longer observation times, but also because in 2013, two of the observatory's 4 reaction wheels broke down, making long-term observations impossible. As a result, astronomers have yet to find an alien Earth. Scanning the heavens. That could now change thanks to a Chinese mission called Earth 2.0, due to be launched in 2026. This mission will scan the heavens for Earth-like planets orbiting Sun-like stars with instruments designed to cope with the star noise that Kepler unexpectedly discovered. The team involved some 300 scientists and engineers from over 40 institutions, most in China, and this week the collaboration published a detailed description of the mission on the ARXIV website. One problem for any space observatory is to cover as a wide field of view as possible with minimizing the cost and weight of the spacecraft. The Chinese team solved this problem by avoiding the cost and weight of a single giant telescope. Instead, the spacecraft will carry 6 smaller 30-centimetre telescopes that together will observe a similar area of the sky as Kepler, which had a 1.4-metre mirror. These telescopes will look for the characteristic changes in star brightness as a planet passes in front of it. The spacecraft will also carry a seventh telescope designed to look for micro-lensing events in which the gravitational field of a star focuses the light from a distant star behind it, temporarily brightening it. By studying the pattern of brightness, astronomers can tell if the star has an orbiting planet. This 7th instrument will also be able to spot free floating planets, thereby helping to cast some light on these strange, lonely objects. The Chinese team plan to launch Earth 2.0 to the L2 Lagrange point, one of several regions of space where the Earth and Moon's gravitational fields are in balance, and away from Earth's potential interference. L2 is a popular choice for observations and home to present past and present, such as the Herschel Space Observatory and the James Webb Space Telescope. The Earth 2.0 spacecraft will orbit L2 over the course of 4 years, sending back some 169 gigabyte of data every day. That raises the prospect of some mouth-watering discoveries. Simulations show that the Transit Survey will be able to detect up to 29,000 new planets, including up to 4,900 Earth-sized planets, the team say. That means the mission should detect between 10 and 20 Earth 2.0s by 2030. The discovery of the first Earth 2.0 is likely to be one of the most defining moments in the history of astronomy. It is likely to create huge interest in the nature of these planets, the makeup of their atmospheres, and the potential, like methane and oxygen, and characteristic light absorption patterns of photosynthesis. Beyond that will be the search for technosignatures that might indicate presence of civilization, signals such as industrial pollutants like fluorocarbons, and even narrowband radio transmissions. Of course, Earth 2.0 isn't the only mission capable of spotting an alien Earth. Several others have the capability, such as the ESA's Plateau mission, P-L-A-T-O, Plateau mission, which will also be launched in 2026, but these will have to be luckier than Earth 2.0 to be successful. That sets the scene for an exciting international race to discover an other Earth and the beginning of a new era in the study of potential habitable planets. You're tuned to ASV Radio VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria in Narre Warren South. I'm in Narre Warren South. The Astronomical Society of Victoria is everywhere, but mostly based in Victoria, Melbourne. Alrighty then, next article. Rocket impact created double crater on the moon. A pair of lunar craters recently excavated when a rocket slammed into the moon may hint at the nature of the human-made impactor responsible. July 5, 2022. And there's a picture here. I'll bring that up. There it is. Away we go. Back to the article. So what you're looking at there, gentlemen and ladies, the eastern crater is about 60 feet, or 80 meters, 18 meters that is, across while the western crater is slightly smaller at 52 feet, or 16 meters in diameter. Last year, astronomers discovered that a rogue rocket body was on a collision course with the moon. The impact occurred March 4, 2022. Now, NASA's Lunar Reconnaissance Orbiter has spotted the resulting crater, or rather, craters. The fact that the collision produced two craters is odd. No previously witnessed rocket body impacts on the moon have created such a double crater. This suggests something about the identity of the rocket that slammed into the lunar surface. And there's just another group of images here I'll just bring up now. There we go. Actually, it's a lovely short article. So those images there, the subtext says that while the Apollo SIVB craters are somewhat irregular and much larger, none of them produced double craters. So in this case, what are they saying? According to the NASA press release, in order to produce such a double crater, the rocket likely had to have a large mass on either end, a feature not usually seen in a spent rocket. Those whose mass is concentrated at the end where the engines reside. This suggests the impactor was either a SpaceX Falcon 9 rocket launched in 2015 or a Chinese 5-1 booster launched in 2014. However, the impactor's true identity still remains unclear, and neither party has yet taken responsibility. But there it is. There's a series of pictures there of the recent impact being photographed by the Lunar Reconnaissance Orbiter. Most fascinating indeed. Okay. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. Just checking for emails. If anybody wishes to send an email signal report, please do. VK3EKH@gmail.com. The camera's not quite on me there, is it? Okay. All right. Now, here's looking back. At a very exciting time with going to Mars. One of the reasons that I got the internet. Sojourner, the microwave-sized rover that showed us Mars. 25 years ago, today, 4th of July, actually, NASA's first rover began exploring the red planet. And I've got a picture there of that. I'll just bring that up. I've been wanting to do that. Okay. When you hear the words Mars rover, what do you think of? Anyway, you probably picture one of the modern rovers like Perseverance or Curiosity, camera-covered, laser-totting, nuclear-powered monster trucks with wheels the size of barrels, trundling across the Mars with all the urgency of a Jawa sandcrawler, Jawa, that is, a Jawa sandcrawler to study rocks and dust. Or, if you're a little older, you might imagine the predecessors, the smaller solar-powered twin Mars exploration rovers Spirit and Opportunity, who raced across the Barsoom like Labrador puppies on a beach, hop-scotching from crater to crater and going up and down more hills than a grand old Duke of York. But none of those would have even been built if it wasn't for the amazing success of a much smaller, much less sophisticated rover named Sojourner that landed on Mars 25 years ago today. Not in reference to 4th of July. Long before these modern machines. Not much bigger than a microwave oven, it weathered a daring landing cocooned inside airbags that didn't just survive but thrived on Mars, carrying out useful science and sending back fascinating pictures before its mission ended. Sojourner paved the way for the high-tech rovers currently rolling across Mars in the same way that the Canvas Cane Wright Flyer Kitty Hawk paved the way for fighter jets and airliners in our skies today. So, what of Sojourner? Most recent entrants to the space enthusiasts' fold might be most familiar with Sojourner's following the rover's cameo in the film The Martian. Ah, yes. Although the way it followed Mark Watney around the Hab like a pet dog was as realistic as the film's dust storm. It was sweet, and it's just one of many things I forgive the film for, the author says. But what is the real story of Sojourner, you might ask? Well, launched December the 4th, 1996 aboard a Delta II rocket, Sojourner was part of the Mars Pathfinder mission, a low-budget program to send a lander and a small test rover to Mars to see whether it was even possible to operate a wheeled vehicle on the red planet. And Sojourner certainly was small, weighing approximately 11.5 kilograms and measuring just 28 centimeters high and 63 centimeters long. It really was the size of a microwave oven. But despite its diminutive stature, little Sojourner had big goals. It had front and rear cameras and a variety of instruments designed to perform limited but useful science or valuable science. Its most striking features, however, were its flat, top-sided, covered in metallic blue solar panels, which many thought made it look like a giant beetle, and its 6 small spiky wheels, which gave the rover real Robot Wars appeal. As nothing like it had ever been tried before, hopes weren't exactly sky-high that Sojourner would work. Many thought that if it did work, it wouldn't work for long and would die after driving a couple of dozen yards or over 7 or so Sols days on Mars. Its planned mission length. But after landing safely on July 4, 1997, Sojourner exceeded all expectations. The Mars Pathfinder lander set down in an area called Ares Valley, which, by the way, is nowhere near and looks absolutely nothing like the place Watney digs the rover out of the sand in The Martian. Oh, that's interesting. The Ares Valley is essentially the dried up remains of a huge channel carved out of the surface of Mars by violent floods billions of years ago. When Mars Pathfinder first image came back, they showed an orange-brown landscape strewn with boulders, some of which were quite large, and almost all of them bearing signs of tumbling, cracking, and splitting by flooding that once swept down the valley. Those images caused a sensation because Pathfinder was the first real space mission of the almost broke under the pressure. Hang on, let me read that again. Those images caused a sensation because Pathfinder was the first real space mission of the internet age. Oh yes, I missed a sentence out there. And I accept that because, like I said, that's the only reason why I got onto the internet was because of Mars Pathfinder. Pathfinder was the first real space mission of the internet age. When NASA began posting images daily, there was so much interest in them that the fledgling internet almost broke under the pressure. Yes. People around the world viewed and downloaded the images as soon as they appeared, and that's what I did, which both gave the mission an incredible public profile and showed that there was a huge appetite for live images sent back from out there. Many of the space enthusiasts who now downloaded the raw images sent back by Curiosity and Perseverance and used them to create beautiful panoramas and views, including myself, the author, first got into the image processing because of those first Sojourner photos. And there's another image here taken by Sojourner. Sunset. Might be a sunrise, but I think it's a sunset. Yes, it's a sunset. So what you're seeing there is the first image taken of a sunset on Mars. Mars Pathfinder sent back this stunning true color image of a sunset on Mars. At left are the Twin Peaks located near the landing site. Quite an amazing image, that one. During its time on Mars, Sojourner visited and imaged numerous fascinating rocks, many of which were given quirky nicknames by mission team. Yogi was so named because it looked like the head of a bear, kind of, and had neighbours such as Pop-Tart and Barnacle Bill. Two hills on the horizon were imaginatively named Twin Peaks, and a wind-carved dust dune close to the landing site was christened Marmaid Dune. Sojourner's low-resolution 0.018 degree per pixel cameras took images of these rocks, which geologists back on Earth used to study their structure and composition. But the best images of the mission were of Sojourner itself, taken by the Pathfinder lander, a camera mounted on a tall mast on the lander. Yes, the same one that swings around pointing at hexadecimal characters drawn by Watney in the movie, took many fantastic images showing the rover trundling between the rocks. Compared to the ultra-high resolution images now being sent back by Perseverance, these photos were little more than snapshots taken by a tourist's camera, but there's a charm about them that modern images just don't quite possess. Sojourner survived for 83 sols on Mars, and in that time drove a distance of nearly 330 feet or 100 meters, never straying too far from its lander, which served as a relay station for signals coming from or going back to Earth. Images taken from orbit in recent years still show the rover close to its lander. Many people want to bring Sojourner back to Earth one day to be cleaned or dusted of dust and placed in a flood-lit gallery in the Smithsonian. Personally, I think it should just stay right where it is on Mars as a testament to the skills and expertise of the amazing engineers and scientists who got there. But whatever Sojourner ends up in the future, the author says, I hope they make a space next to it for the first rover to land on Mars. Then he says, wait, what? ? Sojourner was the first rover to rove on Mars, but a quarter of a century earlier, the Russians sent the very first rovers to the Red Planet aboard their Mars 2 and 3 landers. These Prop-M nano rovers didn't look like rovers as we think of them today. They were tiny, around the size of a large hardcover book, and weighed barely 5 kilograms. Essentially just small square boxes with wide flat skis instead of wheels. The plan was to lower them from the landers attached to the end of a spindly 6-foot long 1.8 meter robot arms. The rovers would then move around the lander as a tortoise-like top speed of 1 meter per hour, still attached by a 50-foot tether. Unfortunately, neither rover did any roving. The first was destroyed when Mars 2 crash-landed on November 27, 1971. A month later, Mars 3 reached the surface intact, but stopped talking to Earth just under 2 minutes after landing, so its rover was never deployed. future Martian archaeologists may find the Prop M still there on the end of its robot arm, hanging just a few frustrating feet above the rocks and dust it was supposed to be trundling through. Well, I didn't know that. Anyway, honouring the past, in December 2006, the Mars Reconnaissance Orbiter snapped a high-resolution image of Pathfinder's landing site. Those shots show the lander and its surroundings, as well as the likely location of the little rover's final stopping point. Sojourner may have passed out of the general public's memory, but it never left that of NASA. While building Perseverance, engineers fitted a long, dark plaque on its chassis, engraved with the silhouettes of the rovers that drove across the Martian surface. Behind Perseverance is Curiosity, with Spirit and Opportunity behind her, and at the very start of the line, Sojourner. Isn't that interesting? Well, I honestly didn't know about those Russian attempts to land on Mars. I mean, we're talking about November 27, 1971. The Russians actually sent a couple of probes, Mars 1 and Mars 2. Oh, am I? Oh, okay. I could probably up the power here a little bit. Let me see if I can do this. Okay, I've just upped the power a little bit. I'm still doing that, aren't I? I don't want to go too high. Let's just leave it there. Just bear with me for a tick, ladies and gents. The repeater, the vision signal on the ATV repeater is doing some funny things. Now, I'm not sure if it's related to the low power that I'm putting out or something else. That's a bit disconcerting, isn't it? Because that'll be upsetting your Discord link too, I suspect. Okay, I'll just pop it up to 0. Oops, wrong one. No, it's going the wrong way. Let's just see, because this will be about 2 watts. No, it's still doing it, isn't it? I don't know why it's doing that. Yeah. All right. Okay, we've got just a few more minutes to go. All right. Actually, interesting. If you can't look at the input, can you, at the moment? Because it'd be interesting to see whether the uplink is stable. I suppose it would be at this distance. I'm not really sure what's the reason for that. Yeah, it's a bit disconcerting, isn't it? Anyway, look, there's one more article here, and then we'll finish up. Yep. Okay. All right. Loads of precursors for RNA have been detected in the center of our galaxy. The heart of the Milky Way is apparently a hotspot for molecules that combine to form RNA. A new study of thick molecular clouds that shroud the galactic center has revealed the presence of a wide range of nitriles, 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 organic molecules that are often toxic in isolation, but also constitute the building blocks of molecules essential for life. The increase in prebiotic molecules involved in the emergence of life, identified in the galactic center, particularly those associated with RNA, as implications for our understanding of how life emerges in the universe and how it did so here on Earth. And here we show that the chemistry that takes place in the interstellar medium is able to efficiently form multiple nitriles, which are key molecule precursors of the RNA world scenario explained by astrobiologist Victor Revilla of the Spanish National Research Council and the National Institute of Aerospace Technology in Spain. Precisely how life emerged on Earth is a mystery whose bottom scientists are extremely keen to reach. That information will yield important clues to discovering exoplanets likely to harbour living organisms. One version is that RNA emerged first from the metaphorical ooze, self-replicating and diversifying all on its own. This is what's called the RNA world hypothesis. We're not likely to ever get direct evidence from Earth, but we can put together more and more clues to figure out how plausible and how likely this scenario is. One of the questions raised by this hypothesis is about the source of RNA prebiotic molecules such as nitriles. Were they here on Earth from the start, or could they have been carried in the form of space on meteorites and asteroids from space? We know the inner solar system, including Earth, was subject to a period of intense asteroid bombardment very early in its history. We've also found prebiotic molecules on meteors, comets and asteroids hanging around the solar system today. Even where do meteors, comets and asteroids get them? Or where do these meteors and comets and asteroids get them? Well, probably the clouds they were born in, cold molecular clouds that give birth to stars. Once a star finishes forming from a section of cloud, the cloud leftovers go on to form everything else in the planetary system: planets, comets, asteroids, dwarf planets, and whatever else might be lurking about. The solar system's birth cloud is long gone, but the centre of the galaxy is thick with molecular clouds. It's called the central molecular zone, and scientists have found a bunch of prebiotic molecules hanging around there. One particular cloud, named G plus 0.693-0.27, is especially interesting. There's no evidence of star formation there yet, but scientists believe that a star or stars will form there in the future. The chemical content of G plus 0.693 is similar to those of other star-forming regions in our galaxy, and also to that of the solar system objects like comets, Revilla said. This means that its study can give us important insights about the chemical ingredients that were available in the nebula that gave rise to our planetary system. The researchers used two telescopes to study the spectrum of light coming from the cloud. When certain elements of molecules absorb and emit light, this can be seen on the spectrum as a dark or lighter line. Interpreting these absorption and emission lines can be tricky, but it can also be used to identify which molecules are present, which one has its own special signature, or each one has its own special signature. By carefully studying and analysing emission features from G plus 0.693, Revilla and his colleagues identified a range of nitriles, including cyanic acid, cyanidine propylyl cyanide, and cyanopropylene. Interesting chemicals. They also made tentative directions of the cyanopropylamide and the other one. Previous observations of G plus 0.693 revealed that the presence of these interesting molecules suggests that nitriles are among the most abundant chemical families in the Milky Way, and that most basic building blocks of RNA can be found in the clouds that give birth to stars and planets. But there is, of course, and always is, more work to be done. We have detected so far several simple precursors to the ribonucleotides, which are the building blocks of RNA, explained astrobiologists, also of the Spanish National Research Council. But there are still key missing molecules that are hard to detect. For example, we know that the origin of life on Earth probably also required other molecules such as lipids, responsible for the formation of the first cells. Therefore, we should also focus on understanding how lipids could be formed from similar precursors or simpler precursors available in the interstellar medium. And that article, you'll find, was published on sciencealert.com on the 8th of July. Okay, we've gone a little bit over time. A little bit of promotion here. Oh yes, I've got a slide for this too. Okay, up for Mount Burnett. Yes, Mount Burnett Observatory. If you're interested in exploring a local observatory, and it looks like, oh no, it's still there. I'm not sure what's going on with that picture on the repeater. Yeah, interesting. Anyway, yes, Mount Burnett Observatory, up there in the hills. It's about a 20-minute drive from Narre Warren South. They've got an open house happening. MBO presents a next public event on the 30th and the 31st of July 2022. And just check out the website for that. Yeah, and of course they had a special meeting tonight too. The MBO meets every Friday night up there at Mount Burnett. So all I can suggest is go to the website at www.mbo.org.au, or just type in Mount Burnett Observatory. Also, we have a little bit of a promo. Oh, that's right. No, we're getting to it. We are going a little bit over time here, but that's all right. Where's my thing here? I didn't transport it across. Let me just add an image. Hang on a sec. Let me just go back to me for a moment. I've just got an image here that I want to bring up as well from astrophys.com. There it is. Okay. So Astrophysics coming up. Astrophysics. All right. The next Astrophys podcast is Astrophys 100 episode 150. It's they're talking about gravitational waves again, and the name of this astrophysicist is Flor Brokengarden. Brokengarden? I don't know. If you can, I don't know why the picture keeps dropping on the TV repeater. YouTube is the other resort here, ladies and gentlemen. But yeah, her name is Flor Brokengarden. She is an amazing astrophysicist doing her PhD in gravitational wave research at Harvard, Massachusetts. She is a prolific GW researcher and effective ambassador for early career astronomers. Flor is a well-established mentor and supervisor for astrophysics students and has been published in highly respected journals. You will hear about her most recent papers where she investigates the first two black hole neutron star mergers detected in gravitational waves, as well as her paper on binary black hole mergers. So anyway, that's the next Astrophys, episode 150. You can find Astrophys by just typing in astrophys.com. And then there's, like I say, there's so many other podcasts there. I might even grab a hold of that particular episode and play that maybe next week in the near future. I don't know, but I'll do a bit of a download and see if I can get that. That's scheduled for June 15, or that was on June 15. So it's ready there to listen to. That's the latest. Okay, spaceweather.com. Let's get there. Spaceweather.com. Let me just, I don't want that. Okay, back to me. Spaceweather.com. We have The solar wind is currently at 414.6 kilometers a second. 414.6 kilometers a second at a density of 6.4 protons per cubic centimeter. Currently on the currently on the disk of the sun, and I do have that image here. Actually, no, I don't. I haven't imported that yet. Oh my goodness me! Let me just bring up the image of the sun. There it is. Okay. So if you're not being able to see it on the repeater at the moment, because something's going really strange up there on the repeater. Okay, the current solar disk of the sun, you can see here the disk of the sun. There are 1, 2, 3, 4, 5, 6 sunspots on the disk of the sun, and spaceweather.com is saying that the Bastille Day event help needed. What is that all about? That's something completely different. Okay, a crack in the Earth's magnetic field. July 7, a crack opened in the Earth's magnetic field and it stayed open for nearly 14 hours. Solar wind poured through the gap to fuel a minor, albeit long-lasting G1 class geomagnetic storm. Okay. This crack was opened by a co-rotating interaction region, CIR, which hit Earth's magnetic field during the early hours of July 7. CIRs are transition zones between fast and slow-moving streams of solar wind. They contain shock waves that often cause geomagnetic storms. NOAA analysts think a CME might have been embedded in the solar wind just ahead of the CIR, thus delivering a double blow. So, yes, the sun is very active as we speak, one way or another. Now, there's an interesting image here I'm going to bring up from solarspaceweather.com. I don't wish the signal on the repeater was good. I don't know why it's failing there. So all I can say is just switch over to the YouTube channel VK3CSJ on YouTube to get the stream there of this interesting image, or otherwise just go to spaceweather.com. What you're seeing on the screen here at the moment is a Kaleido Dossio, the Kaleido Dossio SMO. I don't know how you pronounce that. Every star, what it is every star is a different color. The hue depends on temperature. The coolest stars are red, with surface temperatures of about 3,000 degrees C. The hottest stars are blue, with temperatures up to 40,000 degrees C. The entire range is covered in this unique image of real stars created by Italian astrophotographer Palio Palma. Palma explains, "In these last 2 years, I have photographed with a smartphone all the stars up to magnitude +5 visible from Naples in Italy with my 18-inch Dobsonian. 1,250 snapshots. I put every star out of focus to make the colours clearer. With this mosaic, it is possible to catch at a single glance the innumerable shades of all stars of the celestial vault visible to the naked eye from Italy." He calls it the Kaleido Cosmo. Yep, because it reminds me of looking through a kaleidoscope, says Palmer. Kaleido Cosmo is an artistic astronomical mosaic that reveals how the starry sky is definitely more colourful than we can imagine. And it really is quite an interesting image. For a minute there it stabilised. But that's quite fascinating. What a most fascinating thing to try and do. I've kind of observed this. I mean, like anybody that's stared at the stars through binoculars or a telescope, if you temporarily defocus your image you're looking to, you'll notice how the fine point of a light blows out into a much larger rounded light, and often the colour of the star does become a little bit more apparent. Well, here we are of an image that's been done, a mosaic. That's quite something. That's really interesting to see that. Okay, as of the 8th of July, there are 2,279 potentially hazardous asteroids. So look out for them, okay? All right, I'm going to leave it there. We've gone well and truly over time. So I think on that note, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. And we are now coming to a conclusion. So we shall turn off the medium wave transmitter on 1865. Thank you for listening to our AM service. Any reports for the signal on 160 can be sent to VK3 Echo Kilo Hotel, VK3EKH at gmail.com. There's no other emails that have come through that I can see. And so we shall conclude our service. There won't be any callback on 160, but rather on 80 metres. So any information about the ASV can be found from the website at www.asv.org.au. Thank you for listening on 160. This is VK3EKH concluding on 1865. Stand by. Stations on 80 metres. All right. Okay. Where's my pen? That's a combination of pen and paper. There it is. All right, let's hope the changeover relay in the amplifier behind me clicks in and clicks out when it should. Okay, so I do apologise for the picture dropping out on the repeater there. I just don't know why it's doing that. It's a strange one. This is VK3EKH listening on... Oh, hang on a sec. Before I do, I better switch the speaker over. I'm using one speaker here, so I've got to switch between speaker A and speaker B. It's just one of the many quirks of this shack of mine. This is VK3EKH listening on 3541 for any stations wishing to check in. All right. Yeah, we've got VK3GL, VK7JAH, and VK3HDX. Anybody else? Oh, yeah. All right, VK3BDA. It sounds like the band's fallen over. BDA. Anybody else? No worries, got you there, Steve. All right. We'll go to the top. VK3 Golf Lima, VK3EKH. G'day, Graham. Yeah, thanks, Graham. VK3 GL in Bunyip, VK3 EKH returning. Yeah, not a very strong signal from you. The band is definitely. I don't know what it was like at the start an hour ago, but all signals at this stage are low compared to normal. So you're clearly 5 or 9. I'd give you a +10 if anything, but quite low. So really strange. I've reset the repeater, not the repeater itself, but my system. So I don't know. I'm still not sure what was going on, but I did turn off the TV transmitter and then reset and started it going. It looks like the picture stabilised. So yeah, it's a strange one. I'm not sure what could have been going on there. Anyway, yes, the Sojourner was an interesting time. And like I say, definitely one of the reasons why I got the internet running through Email, I think was the provider. And I mean, you know, we didn't know anything better in those days. To watch a picture from Mars slowly scanning down the screen on your computer was and you knew that image was just fresh, you know, hot off the press. You know, you didn't have to wait till the 6 o'clock news to see it. It was really quite stunning. It was a fantastic time for sure. Thanks, Gray. Yeah, I should be about over the weekend. I'm heading up to Heathcote tomorrow morning for the afternoon. I'll be back by dinner time. But I won't. I'll only have VHF comms in the car. So I'll be on Mount Macedon most likely for part of the trip. Okay, across to you there, Martin. VK7JAH at Launceston, VK3 EKH. Yeah, good on you, Martin. I'm hearing you quite well too. Normally you're just in that noise, just on the noise threshold, but you're coming through quite clear tonight. So it's just across Bass Strait. It shouldn't be a problem. Anyway, thanks, Martin. Good on you. Thanks for calling in and the report. Excellent stuff. Don, VK3HDX. Now you're normally a booming signal here too, but for some reason not as strong as normal. The local skip just isn't happening tonight. VK3HDX, VK3EKH. However, you're pretty good right now.
Evening, Clint. Evening all. Good broadcast tonight. Enjoyed it. Those pictures from Mars still amaze me every time I see them. Excuse me. You're right, signals are down, although, you know, when Graham called in before, he was right down, and then when you called him back in, he's come back up, so the band's definitely doing stuff. And boy, you just brought back memories from me, Clint, when you mentioned Email. I was one of the 6 people that started that company. Back in the day, IINet now, of course, and they bought it, and was Malcolm Turnbull who put up the money to start that enterprise. So glad you were on board back then. I still have my Email address, and it still works. Thanks for the broadcast as usual, and I look forward to next week. The picture when it was up on the repeater was very good, and it it was great on YouTube. So thanks for everything you do, Clint, and we'll look forward to next week. VK3 EKH and the group VK3HDX.
Yeah, thanks, Don. VK3HDX, VK3 EKH. Yeah, you're 20 over 9 actually, so not too bad right now. So yeah, things are definitely changing about, aren't they? Most interesting. Yeah, I think I got rid of that old 56k modem that I had in those days. It was I think it might have been a bit of a package. So if you signed up to Mail, they sent you out the modem too, I think, with all the little connecting tones that you used to hear. You always thought that was pretty cool. All those funny little tones you used to hear. But yes, 1997. That was a year for many things. Carl Sagan's Contact movie and Titanic, all sort of coming around at the same time, and of course Mars Sojourner, and of course that where the Sojourner is, the Mars Pathfinder. I think they've officially called that area the Carl Sagan Memorial, is after his name. That little location there. So if we ever do land on Mars and put a sign up there, it'll most likely say that Carl Sagan Memorial Site, something like that. I believe that's the case anyway. All right. Thanks, Don. Graham, VK3BDA. I think it was. You're a little bit weak when you first called in. VK3 Bravo Delta Alpha, VK3EKH. VK3 BDA in Bendigo, VK3 EKH returning. Yeah, a little bit hard to copy you there, Graham. The signal wasn't very strong at all throughout all that. You barely went above 9, so you're right on the noise floor, and just a little bit hard pressed to catch exactly much of what you said. So I do apologise for that. I just hope that maybe other stations were getting a better signal from you than I was at the moment. So, but anyway, thanks for calling in, and you're in the log, as they say. All right. Of course, VK3BDA is the official call sign for the Bendigo District Astronomical Society, which is a section of the ASV. A section of the Astronomical Society of Victoria, and you can find more information about the BDA, the Bendigo District Astronomical Society by going to the ASV website, looking under the sections tab, and looking for the actual sections for the section for the Bendigo Society there. More information can be found from that. Anyway, thanks, Graham. I'm not sure how well you're hearing me, but yeah, not a very good signal. And I think Steve is a bit the same. Steve's up that way, and yeah, not too good coming in here. VK3 SPX, VK3 EKH, but just a little bit better. Yeah, thanks, Steve. VK3 SPX, VK3 EKH. Good signal from you, though. Quite readable, so not a problem at all. Just hovering about 5 to 10 over 9, so you're just a little bit better than Graham. But yeah, it's funny how 80 metres reacts sometimes. Yeah. All right, I'll take one more listen for any other stations wishing to check in. VK3 Echo Kilo Hotel. Go ahead, Frank.
Good evening, everyone. Good broadcast. Thanks very much. I'm doing it down all right. Your voice, but not strong. Yeah, if the plus is the same number, I think they've all gone on holiday. So we need to change the number for about 4 weeks. Anyway, otherwise, everything's good. I listened to back series. And we also have two new stations, network stations on through the AFE. Not quite sure of the frequencies. 4 and 3.5, I think, and 2.1. Loud and clear from up Indigo Way. Back to you. VK3 EKH, VK3 JR.
Yeah, okay. What was those frequencies you mentioned again?
I'm not sure of them because I don't like to use them out. One was 4.835 or 4.85, and the other one was 2.1.
Okay then. All right. Interesting. Actually, there was something I noticed. One of the folks that comes in on our chat window had something I noticed. Yeah, I don't know what this is about. This is a little news flash thing that's come from our resident shortwave listener up at Brisbane, Daz. G'day, Daz, if you're listening. He says, oh, I see. Okay. I actually didn't read it fully, but this is what you're saying, Frank. Dave VK3 ASC has got himself a shortwave broadcasting license. How does one manage to do that? Anyway, it looks like he's got himself a shortwave broadcasting license. Okay, 2 new HF domestic licenses have been granted by the ACMA. Operational frequencies are 2.31 megahertz, 4.835 megahertz, and 4.835. Oh, it's the same. Yeah, it's funny how that's written. Anyway, 4.835 megahertz signal has been verified. I'm going to have a listen to this and see what that's all about. Thanks, Frank. That just verifies a little statement that that's on my screen here from someone else. So that sort of confirms that too. Oh, look at that! There's a big fat signal on 1865 that's come on. Let me see. Yeah, I've got. Yeah, I can't turn it out because the speaker's selected, but I can see a signal. That'd be Mr. VK3SL. He's come up, and he's about 22 over 9 here at the moment. So there it is on 1865. You can tune in to VK3SL. Thanks, Frank. Good on you. Nobody else wanting to say anything? VK3EKH. All right, that's it. I'm out of here, ladies and gentlemen. Thank you very much, Lee, for tuning and listening into tonight. I hope you found at least one of the articles presented tonight of some value, some interest somewhere along the way. I've got to head up to Heathcote tomorrow to help out with a few little things. So I'll be heading off a little bit early tonight, so I shan't occupy the repeater any longer. But since resetting the TV transmitter here, the signal through the repeater seems to have settled down. I don't know what was going on there. Most peculiar. Anyway, cheers everyone. Take care. Look after yourself. Everybody on the chat window that's come up. Martin, VK7JH, Kim, VK5FUSE, Richard, VK3VRS, Steve, VK3SPX, Mike, VK3XL, just up the hill. Who else is there? Who else? Joe, VK3BKI, thanks Joe. And Graham, VK3GRK, who popped up a moment ago. Thank you, boys and girls, and ladies and gents, and shortwave listeners. Any reports can be sent to vk3ekh@gmail.com. Thank you for watching tonight, and everybody on YouTube, the same. Anybody overseas that's watching this, let me know, and anybody that sends messages in foreign language gets deleted straight away. This is VK3EKH, ASV Radio, concluding on the stream and on HF. Goodbye, everybody. Take care. Have a nice week. See you next week. And the stream. Cheers, everybody, on the stream. Bye. Thank you.